In this video lecture, let me discuss about the EMF series and its significance. The arrangement of various electrodes in the increasing order of their standard reduction potential is known as electrochemical or EMF series. Some metals have been considered here: hydrogen 0 volt, iron above hydrogen, iron minus 0.44 volt, zinc minus 0.76 volt, and the topmost is lithium minus 3.01 volt, and below hydrogen copper plus 0.34 volt, and bottommost is fluorine plus 2.87 volt. Applications of EMF series or significance: standard EMF of the cell. E0 cell is equal to E0 right minus E0 left. Relative ease of oxidation or reduction. Higher the value of standard reduction potential, greater is the tendency towards reduction. For example, consider lithium and fluorine. Lithium topmost, fluorine bottommost. Lithium undergoes oxidation and fluorine undergoes reduction. Anodic or cathodic behavior of metal. Metals lying higher in the series acts as anode, and metals lying lower in the series will act as cathode. For example, consider zinc and iron. Zinc will act as anode, iron will act as cathode. Iron and copper, iron will act as anode and copper will act as cathode. Hydrogen displacement behavior. Metals with negative standard reduction potential will displace hydrogen from acid solution. That is, all the metals which is placed above hydrogen are negative, so those metals will displace hydrogen, and the metals which is placed below hydrogen in the EMF series will not displace. For example, consider zinc. Zinc with H2SO4 forms zinc sulfate and release hydrogen gas. Since one of the product is gas, it may escape, so the reaction cannot be reversed. On the other hand, silver with sulfuric acid, there is no reaction. Replacement tendency of one metal by another. Metals which lie higher in the EMF series can displace metals which lie lower in the EMF series from solution. For example, zinc and copper sulfate. When we store copper sulfate in a zinc vessel, zinc will displace copper. Zinc forms zinc sulfate and copper solid is produced. Predicting feasibility of a redox reaction. If E0 cell value is positive, then the reaction is feasible. If E0 cell value is negative, the reaction is not feasible. Determination of standard free energy change delta G and equilibrium constant K. So minus delta G0 is equal to NF E0. So from the value of E0 we can determine the delta G0. And from Van 't Hoff isotherm, minus delta G0 is equal to RT ln K. So we can equate RT ln K is equal to NF E0, and natural logarithm of K is equal to NF E0 by RT. Converting natural logarithm to logarithm, we get log K is equal to NF E0 by 2.303 RT. Thank you for watching this video lecture.